Handout 5, non-proportional relationships. All right, so if we have proportional relationships, it stands to reason that we would have non-proportional relationships. So let's see what we need to know about them. Okay, first, FitLife Gym charges customers for each month of membership as shown in the table. Use the information to complete A through B. So A says, sketch the graph to show the relationship between the cost of the gym, Y. So the cost of the gym is Y. And the number of months, X. Okay, so number of months, if we have 0 months, the cost is $10. If we have 1 month, the cost is $30. 2 months is $50. And when X is 3, Y is 70. Okay, number 2, or part B says, is the relationship between the number of months and the total cost proportional? So we can do that by X divided by, or Y divided by X. So first we have 10 divided by 0, which is a no-go. We have 30 divided by 1, which is 30. And 50 divided by 2, which is 25. Oh, right there we can see it's not constant. So the relationship is not proportional for a couple reasons. So one, the ratio of Y to X is not constant. And we can look at the graph and we can see that it is, when X is 0, Y is going through 10, not 0. So 2, it does not go, or the graph, let's say the graph instead of it, the graph does not go through the origin. All right, so the last question says, a relationship is non-proportional if the ratio between the two quantities is not constant. Okay, so non-proportional relationships. Let's fill out the dotted boxes. The ratio of Y to X is not constant. Does not contain the point 0, 0. But instead, when X is 0, Y is a non-zero constant, or anything. It could be any other number but 0. Okay, the line will not pass through the origin, or 0, 0. And instead, the graph will cross the y-axis at a point known as the y-intercept. It's where the line is intercepting. Oh, I don't need the hinting. Intercepting the y-axis. Okay, for 1 through 2, complete the graph to represent the non-proportional relationships given in the table. So we are just graphing. Shouldn't be too hard, right? So 1, the table shows the cost of dollars in jumping at Terrific Trampolines, Y, in relation to the hours of jumping, X. So if I jump for 0 hours, it costs me $6. So when Y is 0, X is 6. When Y is 1, when X is 1, Y is 8. When X is 2, Y is 10. When X is 3, Y is 12. We still have a straight line going on there, don't we? Okay, the table shows the relationship between the X values and the Y values, so it doesn't really matter what they are. We can graph them anyway. So if X is 0, which is the origin right in the center, Y is 1. When X is 1, Y is 4. 2 is 7. And 3 is 10. Okay, how can you determine the rate of change in questions 1 and 2? So how we determine rate of change now is looking at how much it changes. So we need to find the change in Y, and we need to find the change in X. And instead of doing Y equals, or K equals Y over X, we're going to say the rate of change equals, and call it M, the rate of change equals the change in Y divided by the change in X. So if our change here is 3 and our change here is 1, the change would equal 3 divided by 1, which equals 3, which means that every time x increases by 1, y goes up 3. So when x increases from 1 to 2, y goes up 3 from 4 to 7. Okay, in the table about terrific trampolines, our change in y is 2, and our change in hours is 1. So if we would say that our change in y divided by our change in x equals 2 over 1, which equals 2. Notice that is how much the cost is changing every hour. It's going up by 2 from 6 to 8 to 10 to 12. All right, let's do the back. Okay, for 3 through 5, use your understanding of non-proportional relationships to answer each question. At Pizza Palace, Rashid orders a pizza that cost $8 plus $2 per topping. Complete the representation to show the relationship between the number of toppings x, okay, number of toppings is x, and the cost of the pizza y. So this is x, this is y. The process is that if we get 0 toppings, we're still paying $8 for our pizza, but we're adding 0 amount of toppings to that. So 0 times 2, and the cost will only be $8. However, if we order 1 pizza, it's going to cost us $8, plus we have to pay for that 1 extra topping, which is $2, which means we will be paying $10. For 2 toppings, we'd be paying 2 times 2, which would be 12. And for 3 toppings, we would be paying 3 times 2, which is 14. And for 4, we would be paying 4 times 2, which would be 16. Notice, our cost is increasing at a rate of $2 for every topping that we add to it. So, over on our graph, if we have 0 toppings, it still costs us $8. 1 topping is 10, 2 is 12, 3 toppings is 14, and 4 toppings is 16. And we could keep up with that pattern and see that if we order 6 toppings, it's going to cost us $20. The equation for that then is going to be that our y equals that y-intercept right there of 8 plus $2 per topping, or we could switch that around and do 2x plus 8. Okay, A says, what is the initial value or the cost of the pizza with 0 toppings? Oh, that's the 0 toppings. The cost is $8. Where do you see the initial value in each representation? When x equals 0. What is the rate of change for the situation? Well, for every topping, we're increasing by $2. So it'd be the change in y divided by the change in x. That triangle means change in. And that's going to be $2 for every topping, which is just $2. Where do you see the rate of change in the equation? And it is multiplied by x, or in this case, the number of toppings. Okay. Mr. Tyne, I'm not sure how to say that, Tyne, asked his students to create representations of non-proportional relationships. Which students correctly completed the task? Explain your reasoning. Okay, so if we look at Ellie, we would want to look and see how much it is changing and going down every time, so that if we ended up at 0, we would need to know if y equals 0 or not. Okay, so 84 to 63 is 21. 21 there and 21 there. So if we go down 21 more, that is going to be 0. So this is a proportional relationship. Gary says that y equals 3x plus 2. Now, if Gary is correct, when x is 0, y will not equal 0, right? Because we're looking for non-proportional relationships. So 3 times 0 plus 2, in fact, equals 0 plus 2, which is 2. Okay, Cedric, same thing. If we put in a 0 for x, do we get a 0 for y? Yes. That means his is proportional also. Okay, and Gary's is non-proportional. We like his. Okay, so Senna, we can tell right away, even though it's a straight line, it's not going through the origin. So not through 0, 0. Can't see that very well, can we? So this is not proportional or non-proportional. Okay, number 5, determine if each table below represents a proportional or non-proportional relationship. Okay, table A. Right away, we can see that it is not at 0, 0. So we can say not 0, 0, so non-proportional. All right, in table B, we can see that the change here is 14 and the change here is 1. So if I go down to 0, does my y equal 0 or not? So if I go, let's see, if I go up here, my change is still 14. So I need to go down 14 here. 14 minus 14 would give me 0. So goes through 0, 0. So proportional. All right. I think you guys can now figure that out.